A new chapter is being written in Indian space history. One of these satellites, which is going to be a really exceptional satellite and one that has a potential to be game changer, is being launched. That is 12th of August is one of those days that is going to be remembered in general. It's a brand new satellite that is going to be launched, and this is one of these satellites which will go to form a major landmark. This satellite has a capability to change a lot of things and will go on to change a lot of Earth observation systems that has so far taken place in the country. This will also go on to mark the resumption of services which has come to a halt during COVID-19, because this is one satellite that was halted on March 8th, 2020, and that is going to be again resumed. This is one satellite that is going to be a 4-meter Ogive shaped satellite. That means its shape is going to be completely different from the other satellites that so far we have launched in this case. The satellite is going to be in a geosynchronous transfer orbit. And that orbit is, as you can go to take a look at it, this is the one orbit that we are going to talking about. It's moving from one part of the Earth to another part. In contrast to it, there is a sun synchronous orbit that goes on to move from poles to pole, while the one that is going to be in geosynchronous orbit, that remains the place where it is going to be. It is constantly looking the whole of the Earth, and it is going to be in sync with the Earth. This is a better picture, and you can go to take a look at it. That's the way that the sun synchronous satellites move from one pole to another pole, and that is the way that they're going to give their pictures as well. And the satellite, as it goes on to move in a sun synchronous orbit, that is from poles to pole, it opens its camera, and as it opens its camera, it films these regions, and in that process it is able to map the whole of the Earth, not in a one go, but of course through many aspects and through many cycles of it. These are the two forms by way of which you can actually go on to see how is it that the sun synchronous satellite goes on to function. So GISAT is going to be in the geosynchronous transfer orbit, meaning that it is placed exactly at 36,000 or 36,500 kilometers or 35,600 kilometers, constantly facing the Earth. That means it is going to be in sync with the Earth. It is going to be in synchronization with the whole of the Earth. GSLV is going to be 4th generation vehicle with a 3-stage rocket, 4 of which is going to be liquid strap-ons. That means it is going to be strapped to it. And of course, it is one of those rare things. It had been developed with indigenously developed cryogenic engine. Now, this satellite, as we talk about, is an Earth observation remote sensing satellite. It has some of these payloads of remote sensing satellites. And when we say that it has some payloads, it basically means that it can go on to sense certain things on the Earth by way of its radiation being emitted by the Earth. It has those type of payloads as well. That means it has those type of instruments as well. And these are the type of satellites that can be used for a variety of purposes. Means they can be used for the purpose of environmental monitoring, that can be used for the purpose of meteorology, that means for weather conditions, and that can also be used for the purpose of mapping the whole of the Earth, and that is why we talk about cartography in this case. Now, such type of satellites are always going to be very, very different. I mean, they're going to perform a variety of functions. These satellites help to monitor our environment. That is one part. And how is it that they're going to monitor our environment? Because they're going to sense the temperature. Consequently, what they can go to do is that they can always go to tell us the temperature of the Earth. They can go to sense the vegetation. So consequently, what they can go on to do is they will go on to let us know where exactly is it that the vegetation is decaying. They can go on to track and manage disasters, because such type of a satellite that is being launched that is going to be taking photographs at regular interval, and a cyclone can be mapped. In this case, even thunderstorms can go on to be mapped. In this case, a lot of lightning and other things that is taking place that can go on to be, and consequently this is used for the purpose of policy making and for sustainable development. It is this policy making of sustainable development that can be used. Therefore, these are the type of satellites that can be used for the purpose of tracking ocean salinity. That is, how much saline the ocean body is. Now, this is significant because ocean salinity is used for the purpose of checking evaporation, how much amount of evaporation is taking place. It is also going to be used for the purpose of ice thickness. That means that is how much is the thickness of the glaciers, and to what extent is it that these glaciers are likely to be melting faster or slower. Crop health, because it is inherent in the color of the crops that the health of the crop can be known. A green coloration is going to be different, a yellow coloration is going to be different, and all in all it is going to be air quality. That is because it can go on to sense, it can go on to see through the clouds as well, and also with a cloud cover and without a cloud cover, both of them, it can go on to know how much amount of a haze is going to be on the surface. And these are the Earth imaging satellites which go on to take satellite pictures, and of course this is going to be analogous to that of a photograph, and this is a photograph that is going to be ultimately interpreted by some specialist for the purpose of giving this information. Now there are going to be two types of Earth observation satellites. One of them is going to be an active type. Now, active type is the one that transmits energy towards the Earth and measures return signal. That is, the satellite itself will go on to transmit this energy and then go to measure the returned signal. Second is that it goes on to provide information about the Earth's surface, and active satellites can go to see through the cloud because in this case the satellite itself is giving these signals. While the passive satellites, passive Earth observation satellites, they only go on to monitor the direct radiation reflected off the Earth's surface. Now, when we go on to say it so, it basically means that is Earth, when it goes on to get heated, it sends off and emits some amount of a light back into space. And when it emits this light back into space, this is going to be in the form of electromagnetic radiation that is going to be tracked by the satellite, and accordingly it goes on to have an imprint tone on its photographic plate, and it is this tone that is going to be ultimately measured. It is going to be known for the purpose of interpretation, and what exactly different type of colors go on to denote. These passive satellites are not able to work through the clouds. They provide signals through different spectrums and in different bands. That's why we are going to be calling them as multispectrum, or a spectrum that goes on to crisscross a lot of things. These are the two forms of it and two types of it. Now, these satellites, when we're going to be talking about it, they range from they have a different type of an orbit, and of course, we talked about two of these type of orbits. One of them is going to be sun synchronous, that goes on to move from pole to pole, north to south, while the geosynchronous one is the one that is going to be fixed. And these satellites, if it is going to be a geosynchronous orbit, they will go on to continuously emit data, keep on emitting this type of a data, and some of them will go on to emit a data that is going to be so reliable and at a regular interval that can go to change the complexion of how exactly that we can go to see some of these things. Of course, the data in this case is going to be stored on board the satellite, unless it is going to be inside of a ground station to downlink the data, and then the data is going to be sent back to the Earth. Now, supposing an image has been taken by this Earth observation satellite. The time between an image being taken and being available to download can range from maybe a few minutes to it can go on to be months as well, depending on how is it that we and what type of technology is it that we are going to be using. And when we are saying that is the type of technology, that means a lot of things. It is this downlinking that will ultimately go on to go down as one of the most important components. And the download ranges from month to maybe even 1.5 months as well. These satellites are owned by different companies and they are going to be used also by different type of data providers. For example, after some time when we are going to be talking about the privatization of the space industry in India, you know that what will happen sometime later is that these are the type of satellites which will be being owned by private agencies, and these private agencies will go to own it, provide data, interpret the data, and accordingly go on to take it forward as well. So GSAT is going to be in a position to provide a veritable revolution to the private sector in this case, and that is going to be one of the most important features of this satellite. The current operation system is in geostationary orbit. It's not in sun-synchronous orbit, but it has some of the instruments of a sun-synchronous orbit as well. And the data that will be provided, that means the picture that we're going to take, that is going to be used for the purpose of agriculture, to get to know about the depth of the groundwater, to get to know about how is it that the urban areas can be planned, how is it that even the rural areas can be planned in the sense where exactly trees can be planted, how much is the water availability in that place, which are the water bodies that have dried up, where exactly is it that the minerals are going to be found in this place, and mineral prospecting, that is what it means, and a range of applications including forestry and disaster management as well. Disaster management bit will go on to let us know where exactly is a tropical cyclone taking place and how is it that the tropical cyclone will go on to progress. So far we have been receiving this data about tropical cyclone at an interval that is maybe 12 hours, 6 hours, but this is one satellite that will start providing this data at a much more regular interval, only at an interval of 5 minutes as well and 30 minutes as well. Now GSAT will go on to image the entire of India in just 4 or 5 times on a daily basis. That means it has the capability to provide the image of India every 30 minutes, and we can go on to use it 4 or 5 times. Normally most of these satellites go on to be using 12 hours in the whole of the day, and sending in the key data will go on to provide different environmental parameters of the changes in it. For example, maybe the moisture conditions are going to be changing, maybe that the vapor conditions in this case, maybe that the tropical cyclone is brewing, it is just developing, and if we have taken it at an interval of let's say 2 hours, 2 hours, 2 hours, we'll come to know how fast is it that the tropical cyclone is actually developing in that place. And even if there is some amount of a tilt that we are observing in any type of a mountain, we can go to know that there is one area and one region of a major landslide that is going to be taking place. Thus, this satellite will go on to provide real-time imaging of large-scale natural disasters, which are going to be episodic or even short-term events as well. And when we say episodic, that means at what interval is it that this is going to be taking place? That is episodic. And when we say that there is going to be a short-term event, that means maybe even for some amount of time. That means there is going to be a real chance of a flash flood and thunderstorm is brewing, or a cloudburst is going to be taking place. It can go on to provide that part as well. And that is why we say that it will going to enable a real-time monitoring of the natural disasters like floods and that of cyclones, because it is going to be providing us with a half an hour, maybe 2 hours of a picture in this case, and consequently will be in a much better position to map the whole of the region. Now, the basic objective of this mission is going to be the provision of data and provision of pictures, which will going to help us in agriculture, in forestry, mineralogy. But the most important part, which is why we are saying that it will go on to be a game changer, is because it will go on to monitor the entire of the borders and any amount of a change that is going to be taking place all along the border region. And when we say that is it is going to be monitoring border. That means any type of a troop movement taking place on the border. Maybe if someone is going to be building a bunker in that place, it will going to take a picture, and then again after half an hour, then again after half an hour. Normally what we'll going to do is that we'll go on to take this type of a picture at a very large interval. That means maybe 12 hours. This will going to provide a very fast information to us, and that is with many features. One of these features in this case is going to be, it has a 700mm Riche Crescent telescope. Now that means it can go on to provide some type of information about some other things about which we don't going to know too much right now. Of course, this satellite is going to be used for the purpose of defense and surveillance purpose as well. It has a jittery-free platform. That means the photography is going to be very clean, very clear. And it has array detectors. It has the array detectors are going to be, that means it has some of these type of instruments that will going to detect near infrared and short wave infrared bands as well. That means the radiation that will be emitted by the earth. Now why it is significant? Because different objects of the earth, including our body, emits radiation in different wavelength. For example, if there is a warmer body, that will go on to be emitting radiation in a different wavelength. A colder body will be in a different form. An animal, let's say a leopard, will go on to emit radiation that can be tracked, and this radiation will be different from that of a human being. And this is what exactly is going to be tracked as well. It also has electronically steerable phased array antenna. That means we don't have to tilt the whole of the satellite. What we can go on to do is that this antenna itself will go on to change, and it will go on to create a beam of radio waves that can be electronically steered to a point in different directions without actually moving the antennas. That means it can go on to go sideways, it can go on to go vertically as well, and that is a major advantage because it will go on to make it cheaper, at least cheaper to obtain the data. That is where the advantage is. It has also got what we going to say multispectral and hyperspectral bands, and which will go on to provide a real-time picture of the large areas of country. That means at that point of a time, not that we have to wait for it, and that can go on to provide every 5 minutes or the entire of the Indian landmass every 30 minutes at 42 meter spatial resolution. Just imagine when you start getting pictures of India every half an hour, you can actually go on to know a lot of things with respect to movement of the troops, changes taking place on the border, changes taking place in the cyclone, changes taking place in the origin of the tropical cyclone, changes taking place in the area being covered by the floods, and how is it that the flood water will go on to move. Let's say you have got this information. What we'll go on to do thereafter is that we'll go on to use this information on floods and go on to use it on a GIS platform, that is Geographical Information System, and then you will be in a much better position to predict, that is how much area the flood is going to be affecting of any region. That will go on to become one of these major advantage. Of course, it has onboard high resolution cameras. The satellite will allow the country to monitor the Indian landmass and the oceans, but almost continuously. That means all of the pranks that the Chinese are going to be playing in this case, that will be gathered. All of the pranks that the Pakistanis are going to be playing in that region, that will be known. Any amount of movement that is going to be taking place in the oceans, that will also be known, and then we will be much better positioned to monitor whatever that is happening in Malacca Strait, whatever that is happening in Hormuz Strait as well, other than what all that is going to be happening all along Tibetan border, all along the Arunachal border, all along whatever Pakistan is going to be doing on its illegally occupied territories in the country as well. And maybe the terrorist bunkers and other things, it will be able to know it, and it will be able to gather this information and give this information as well. That is going to be the biggest advantage. This satellite was going to be, that's the reason that we're going to say it's going to be a game changer. Now, it is a game changer for a variety of other regions as well. I'll let you know what will going to happen now. That is, we already have some of these satellites like that of Cartosat. So what Cartosat will go on to do is that Cartosat goes on to provide you picture of a territory, and it can also go on to trace something like a 30 centimeter of a mound on the surface as well. It can go on to see through some of these type of foliage of the trees as well. Now, the GSAT has mapped a region, and we need to understand and we need to know about a place which is going to be a small place. Let's say Cartosat has given us this information, we'll go to refurbish with GSAT, and if GSAT has given this information, we'll go to refurbish with Cartosat as well. Both of them are going to be combined. One of them is in sun synchronous orbit, another is going to be in the geosynchronous orbit, and the conclusion that we're going to ultimately reach is going to be actually very, very good in this case. And when we go to reach this conclusion, of course, our ability, our policies in this case will go on to be very good. Incidentally, this was one of those satellites that was going to be launched in March 2020, but it is going to be launched in 12th of August, and because of all of these features, we're going to be calling it as a game changer as well. This is the basic reason for it being a game changer. Now, there is another point associated with it. That is, with so much amount of information that we're going to have, with so much amount of data that we're going to be collecting, we require to refurbish our ground station conditions, but that is going to be in our hand. It doesn't require a satellite for that purpose. Once this satellite is going to be placed in orbit, our security will be strengthened. Once this satellite is going to be placed in the orbit, then our weather conditions and how is it that we can go to predict a disaster will going to become easy. Once this satellite is going to be in place, you will imagine that the damages that is taking place from floods or any of these type of conditions will also go on to be much less. Just wait for it and enjoy the launch of this satellite.
To have more such discussions and analysis, subscribe to our channel and hit the bell icon for notifications on our upcoming videos.